Okay, so you should have this all done. So you have 1, 6, and then 15, 20, 15, 6, and 1. And it should be symmetrical too, by the way. Like if you kind of imagine a line, draw in the middle, it should be symmetrical left and right. And just create one extra row right here because we're going to use it very soon. Okay, so that's why I want you to write down an extra row for 7. Okay. Now, there's actually a few more patterns that we can observe. Like for example, if this number is 2, how many numbers are in that row? 3 numbers. Okay. If we have a number 3, how many numbers are in that row? 4. If the number here is 4, then how many numbers are in that row? 5. Okay, so that also gives you a little bit of a good checking mechanism here. Now we have some space to the right, and what I want you to do is to do the following. Can you go ahead and do a plus b squared really quickly? A plus b squared. I hope nobody would write down just x squared plus y squared. Nobody, I hope. Okay, what would it be? What did I say? Yeah, a squared plus 2ab plus b squared. All right. So now, why am I asking you to do this? Let me ask you a quick question. What's the coefficient here? 1, right? And what's the coefficient here? 2. What's the coefficient here? 1. Did we see 1, 2, 1? We saw that here, right? So the brilliance of Pascal's triangle is that it helps us get the coefficient, or the coefficients, actually, here, of these terms. And if you observe the terms, there's one more pattern that you should see here. Look at the power. Look at the exponents. Look at the exponents of a, actually. First, what can you see about the exponents of a? It goes from 2 to 1, and then to 0. A, the power of a. Well, you would say, well, wait. What do you say? A to the 0 power? Well, the reason why you don't see a at the very last term is because what's a to the 0 power? 1. So for a, the power is descending from the highest number, and the highest number is indicated where? Well, right here, because a times a is a squared, right? So 2, and then 1, and then 0. What about b? It goes from power of 0, like b to the 0 power, and then b to the first power, and then b to the square, second power. So now it's a little bit like it's some mechanical work, okay, very mechanistic here. Now that we are a little bit familiar with the pattern, then we say, all right, now how about this? How about a plus b to the 4th power? What would it be? Okay, what would it be? Now we have a Pascal triangle right next to us. And we say, hey, which row do you think we are looking at here? Well, the one with the 4, right? So first, let's make our lives easier by writing down the coefficient first. What are the coefficients? 1, 4, 6, 4, 1. So 1, 4, now leave some space. 6, 4, and 1. We know that it's going to be some kind of polynomials, and it's going to have these coefficients. So let's go ahead and write down these coefficients first so that we don't have to worry too many things at a single time. We can handle things one at a time. So we got the coefficients done. Now, let's take care of the a term. The first term right here, it's a to the what power? 4th power. The next term will be a to the what power? 3. And then a square. And then a to the first power. And then a to the 0 power, which you don't have to write it. All right. And now on to b. Well, first term is b to the 0 power. Don't have to write it. And then b to the first power. And then b squared. And then b cubed. And then b to the 4th power. All right. One thing at a time. I would not recommend that you do one term at a time. I think that would be a little bit too difficult, a bit too busy for your brain to work out all these numbers and terms. Now, I want you to look at your paper and look at the exponents of a and b together. Among all these terms, can you see something special? Can you see something special among all the terms for a and b? Exponent. Can you see something? They add up to 4, like this is 4, okay? And then this would be, 3 plus 1, right? 4. 2 plus 2, 4. 1 plus 3, 4. And 4. Now, technically speaking, if you know how things are coming together, you cannot make a careless mistake. Just can't. Okay? So that's how we utilize this Pascal triangle to help us do something, and this something is known as a binomial expansion. Like, think about this. If I ask you a plus b to the 4th power without teaching you Pascal's triangle, what kind of nightmare would it be? You'd be like, yeah, so you can do the FOIL first, right? You can square them first, and then you just have to, square again. But afterwards, you have to do the FOIL with 3 terms, and I'm going to start crying. Okay, the carpet will be all wet because I have so many tears by expanding these terms. That's a nightmare. But with Pascal's triangle, it's not a nightmare at all. And if you have something like the example right here, what about a plus b to the 6th power? And we're like, oh, cool, 6th power, we can handle this. Let's go ahead, take care of the coefficients first. 1 plus 6, and you want to again leave some space for you to write down the terms. 15, 20, 15, and then 6, and then 1. Okay, how many terms are there? There are 7 terms. We expect to see 7 terms. Okay. And then what about the other ones? What about the other ones? We have a to the. Well, we're starting with a to the 6th power, a to the 5th, a to the 4th. So it's like fill in the blanks. I would say it shouldn't take too much of a brain power to get this done. I hope you agree with me too. Okay. And then b, and then b squared, and then b cubed, and then b to the 4th power, and then b to the 5th power, and then b to the 6th power. And just to double check, look at the exponents and see if they all add up to, well, in this case, 6. If all are good, done. Okay. So this is like a level 1 kind of work, okay, using the Pascal's triangle to get the coefficients. You understand how the power is going up and down for those 2 terms. Again, it's binomial, so only 2 terms in the parentheses. So nothing's too challenging right here. All right, any question for this?